Today we're going to look at section 5.6. This section is all about proving that a quadrilateral is a parallelogram. So if we remember from the previous section, if we know that we have a parallelogram, there are 5 different properties. So remember, if you have a parallelogram, then we know opposite sides are parallel. If we have a parallelogram, we know that opposite sides are congruent. When we start with the parallelogram, opposite angles are congruent. When we have a parallelogram, consecutive angles are supplementary. And then finally, the last property is when you have a parallelogram, diagonals bisect each other. So we're going to be taking the majority of these properties when we know that we have a parallelogram, and we're going to be able to use them to then do the opposite. If we want to prove a parallelogram, we're going to have to understand some of these properties first. So 5 properties of proving a parallelogram, and I'm going to write it as the shorthand for how you're going to be able to write it in your proof. So if both pairs of opposite sides are parallel, so remember there's our symbol for parallel. So when that's the case, then we know that we have a parallelogram. So we can then just write that symbol. So that is one of the ways in which we can prove a parallelogram. We have to have both pairs of opposite sides parallel. The next one would be if both pairs of opposite sides are congruent. That is enough information to prove that we have a parallelogram. Now, this next one is going to just slightly differ from those 5 original characteristics if we started with the parallelogram. Another way to prove that you have a parallelogram is if one pair of opposite sides, so up here, sorry, I should have said opposite sides. So opposite sides are both parallel and congruent. That's enough information to prove that we have a parallelogram. We also can, so that is a lot of them, but that deals with the sides. So any aspect with sides, either both sets of sides are parallel, both sets of sides are congruent, or one set are both parallel and congruent, that can prove a parallelogram. The next deals with the angles. If both pairs of opposite angles are congruent, that's going to be enough information to give us a parallelogram. So while we could use the property if you have a parallelogram to state consecutive angles are supplementary, we're not using that as a way of proving parallelograms. So that'll be the only angle that you need. That's the only relationship with angles in order to prove a parallelogram. The last one would be if the diagonals bisect each other. That would be enough information to prove a parallelogram. Okay, so once again, we've got our sides, our angles, our diagonals, all different ways of proving a parallelogram. So let's dive into some examples here. Notice that I am giving you a parallelogram, but at the very end, I also want us to prove another parallelogram. So let's start with that ACDF is a parallelogram. Okay, so just to kind of help us out, I'm going to highlight that. So notice that for us, it is this big 4-sided shape right here. That is what's given to us as being a parallelogram. So remember, there are technically 5 different properties of a parallelogram. And so in order for us to kind of figure out what properties might be useful, it might be a good idea, because we are going to have to expand on that, but it might be a good idea first and foremost, let's maybe list any other given information to get more markings in the picture, and then we can go back to the original given information and we can figure out what properties best suit us here. So I'm going to move on to the next given, that angle AFB is congruent to the angle DCE. Okay, so if I follow the letters carefully, AFB, that's this little angle right here, and angle DCE is that little angle right there. All right, so if I want to try to prove, and let me use a different color, but I want to try to prove that this shape inside is a parallelogram, we want to think about those 5 properties that we just talked about. We're either trying to get some information with sides, with angles, or with the diagonals. Hopefully you notice that there are no diagonals in what we're trying to prove to be a parallelogram, so that property is not going to be used. And also in the big highlighted yellow, I don't have diagonals either, so that's not going to be useful to us when we expand on that first given. So kind of a good thing to look at there. So I am probably going to want to do something with these triangles off to the sides, since I have some angles marked congruent in them. So let's maybe focus on that. Let's try to prove that these triangles are congruent. So what properties of that big yellow highlighted parallelogram are going to help us there? Well, one thing would be that angle A can be congruent to angle D, and that's because when you start with a parallelogram, we know that opposite angles are congruent. And so I'm going to mark them differently than the angles that I marked from my given. But now notice that I have 2 things marked in those triangles. We still have more properties of that parallelogram that we can continue. Notice that the side of AF is one side of my parallelogram. And so notice that DC is the side that's directly across from it. Those 2 are congruent because when you have a parallelogram, opposite sides are congruent. Okay, so now that I have that, I have enough information to prove that those 2 triangles are congruent. So I can say that the triangle AFB is congruent to the triangle of DCE. And that's because if you look at the markings, we have angle, side, angle. So notice that my first set of congruent angles came from step 2. My congruent sides came from step 4. And then step 3 got me my other set of angles. Okay, so now that I have that, notice that how is those triangles going to help me with that highlighted green shape that I want to prove? Well, notice that there's some sides of the triangle that are attached to the sides of that green, what we want to be a parallelogram. So we can say that the segment of FB is congruent to the segment of CE by corresponding parts of congruent triangles are congruent. So notice that that gives us then one side of opposite sides are congruent. Okay, so that means that I want to focus on sides here. So remember those first 3, we have opposite sides are congruent, opposite sides are parallel, and then one pair of opposite sides are both parallel and congruent. So the fact that both pairs of opposite sides parallel, these aren't parallel, so that cuts that out. So it's either I want to get the other side of opposite pieces to be congruent, or I want the same set of sides to be parallel. To be parallel, you have to have relationships of angles. So that means we would need some kind of transversal that kind of then gets us angles that are either, alternate interior, alternate exterior corresponding. And I just really don't see that happening here. So that means that my goal probably should be to try to get the other 2 sets of sides congruent. So kind of going back then to step number 4. Okay, I'm actually going to kind of group something else. So yeah, AF and DC are opposite sides, but so are FD and CA. So notice that those two, like this big side right here and this big side right here, these are opposite sides. And because we had a parallelogram, we know that those are congruent. Okay, I'm also going to say with CPCTC, notice that my sides of AB would be congruent to the side of DE because they have the triangles congruent, so any other pieces are congruent. So notice that by having AC marked up and by having AB marked up, they can be subtracted to get that other little piece of BC. And same thing at the top, the big side of FB, take away the small marking of ED, and you're left with the side that we want. So my 7th piece would be that the side FE is congruent to the side of CB because of the subtraction property. So I'm starting with congruent big pieces. So that would be that side of AC, that's a big piece. And that would be the side of DE, DF. Okay, so there are my 2 big pieces, and now I'm subtracting the smaller congruent pieces from it. So that would be the side of AB, and that would be the side DE. All right, so then notice that with lots of markings going on here, but if I look at that green highlighted shape, now I have both pairs of opposite sides to be congruent. So I have enough information to prove that FBCE is a parallelogram. And so because I'm trying to prove a parallelogram, that has to go second when I'm stating it. So remember, if both pairs of opposite sides are congruent, that gives us a parallelogram. And there is our proof. So quite a bit of information going on there. Just got to take it step by step. Marking up your picture is the best bet. Okay, let's take a look at this next one. We are given that the triangle CAR is isosceles with a base of CR. Okay, that's something that we can expand on because when you're given isosceles, that's a vocab word. If I'm thinking about triangles, I know that an isosceles triangle has 2 sides congruent. So if CR is the base, that means that AC and AR are what we call the legs. And so those 2 are congruent because legs of an isosceles triangle are congruent. Okay, so that's how I expand on that. Moving on to the next given, I know that AC is congruent to BK because that's given information. So let's think about this. AC is already marked with 1 tick mark, so now I get to mark BK with that. And so if you look at the picture, notice that we've got 3 different sets of segments that have the same marking. So notice that since I listed in step 2 and step 3 AC twice, I can actually then say that AR is connected and congruent to BK. And remember, that's something called the transitive property. We're linking different pieces together. Okay, so that's important because notice that what we're trying to prove is that the BARK, so this four-sided figure right here, we want to prove that that is a parallelogram. So if you're thinking about the 5 different ways to prove a parallelogram, notice that I just got one set of opposite sides to be congruent. So that takes away the fact that we're not going to be talking about diagonals bisecting each other because there are no diagonals in this picture. We're also probably then not going to be wanting to talk about opposite angles being congruent. We want to focus on sides. All right. If I then continue with the next piece of given information, I know that angle C is congruent to angle K. So those two pieces are congruent. Okay. However, let's think about this for a second. I know that because I have an isosceles triangle and I have then the two legs congruent, I actually can continue to expand on that just a little bit further. Remember, I can say that angle C is congruent to angle, and now I have to be careful, I have to use 3 letters, ARC, and that's because if I've got two sides congruent in that triangle, then the two angles directly across from them are congruent. And since angle C is already marked with that one marking, I get to mark angle ARC with the same marking. And so then we're kind of at the same point that we were with the sides. Notice that I've got 3 sets of markings for those angles that are congruent. And notice how in 5 and 6 we have angle C listed twice. That means that angle K is congruent to the angle ARC by another transitive property. If you wanted to, you could just say same as 4. Okay, so how is that information going to help me with proving that we have a parallelogram? So I know that because I have one set of opposite sides to be congruent, it's that I either want the other set of sides to be congruent or I want AR and BK to be parallel. And so because I can't really do anything to get the other sets of sides congruent, we do want to focus on the idea of parallel. And remember, you get parallel lines because you have different angles congruent to each other. And so specifically, the angle K and the angle ARC, those are a particular type of angle. Notice that they both fall on the side of CK. That's like the transversal. AR is forming angle ARC. BK is forming angle K. What we have are really corresponding angles here. So because those corresponding angles are congruent, I have enough information to say that the side AR is parallel to the side of BK. So I know that because I'm trying to prove parallel, I have to say it second. But I have corresponding angles that are congruent, and that was enough information to give me parallel lines. So remember, parallel means that you've got those little arrow-like things here. Okay, so maybe just kind of help you for a second. Let's look at if I was to highlight it. So remember, there's my transversal. This side of BK is forming angle K. This side of AR is forming angle ARC. So notice how what I highlighted in green kind of looks like an F. It's laying on its side and it's kind of backwards, but that's what told me that I'm dealing with corresponding angles because they both are on the same side of the transversal, but one's interior and one's exterior. And so because I have all of that, I have enough information to prove what I want. I can say that BARK is a parallelogram, and that's because if one pair of opposite sides are both parallel and congruent, that gives us a parallelogram. Okay, let's look at this last one. So notice that, once again, I'm giving us a parallelogram to start with. And so that means that they're going to be able to expand on this, but maybe not quite right away. So let me highlight what I know is a parallelogram. So for us, that is this bigger shape, NRTW. Okay, so I know that I'm going to use that and the different properties to try to prove that at the very end, I want this inner four-sided shape, I want this to be a parallelogram, okay? So we're starting with what's in yellow. We want to prove what's in green to be a parallelogram. Okay, so like I said, I'm going to be expanding on step number 1, but maybe listing all the other given information first is going to be more useful to us at this particular moment. So notice that the side of NX is congruent to the side of TS. And just so you know, I don't normally do this, but I'm going to run out of room if I don't. I'm going to list that both those given congruent pieces on the same line, but I would really suggest that you do them separately, and please don't do that on like a quiz or a test. But I just know from this proof, I know that I would run out of room if I didn't do that. Okay, so I'm going to mark each set of those. So NX is 1 tick mark and TS is 1 tick mark. NP, I'm going to give 2 tick marks, and TV, I'm going to give 2 tick marks. All right, so notice that those 2 sets of sides that I just were given to be congruent are actually a part of triangles off to the side. And so notice that angle N and angle T are in those triangles, and notice that they are across from each other in my big yellow highlighted what I already know is a parallelogram. So I'm going to say that angle N is congruent to angle T, because when you have a parallelogram, I know that opposite angles are congruent. And so that's enough information to state that those 2 triangles, moving on to step 4, are congruent. So triangle XNP is congruent to triangle STV. And that's by, if you look at the marking, side, angle, side. So my first set of sides came from step 2. Step 3 got me my angle. Back to step 2 to get my other set of sides. Okay, so why is having those triangles important? Well, notice that the triangles that I just proved to be congruent are going to be some of the connected to sides that are on that green highlighted parallelogram that I want. So I'm going to say that the side of XP is congruent to the side of SV, and that is the fact that corresponding parts of congruent triangles are congruent. So I'm going to mark them congruent. So notice that I have one set of opposite sides to be congruent. That means I either want the other pair of opposite sides to be congruent to state a parallelogram, or I want parallel lines with what I already marked congruent. So if you look at that last piece of given information, notice that I'm telling you that the triangle of WXV is congruent to the triangle of RSP. And so why would I give you congruent triangles? Well, it kind of matches what we just did in step number 4. With the other 2 triangles that are congruent, I noticed that they have angle W and angle R, which is across from each other from the big parallelogram. So I'm going to say that angle W is congruent. Oh, sorry. No, I'm not going to say that. I'm not going to use the angles. I want to try to get the highlighted green shape. And so I'm going to deal with the sides. Okay, so notice that the side of XV is congruent to the side of SP. And that is also because corresponding parts of congruent triangles are congruent. And so notice that that then gives me enough information to state that I have a parallelogram. So I can say that XPSV is a parallelogram. And this would be because if both pairs of opposite sides are congruent, then I have a parallelogram. Okay, so that's us proving that a quadrilateral is a parallelogram.